Okay, so we've got y equals tan theta for these. Let's actually look at the tan theta itself. So first of all, the domain of y equals tan theta, you can see there's asymptotes at halfway between 90 and 180, well, halfway between 0 and 180, so domain theta, you can't put in 90, you can't put in 270. Where is tan theta equals 0? Tan theta equals 0 at theta equals 0, theta equals 180, theta equals 360. Hence state the domain of tan theta, 1 on tan theta. Well, that makes sense because you can't have 1 on 0, so domain of 1 on tan theta, theta does not equal 0, 180, 360. Like, we're going to have asymptotes at those points. What is the limit as theta tends towards 90, 1 on tan theta? So what that means is, have a look at when theta is 90 for tan theta is 90, like, that's along this line. And you can see tan theta is getting bigger and bigger and bigger, isn't it? So the limit as theta tends to 90 of tan theta, it's going to tend towards infinity. So the limit as theta tends to 90 of 1 on tan theta is going to be like 1 on infinity, so it's going to tend towards 0. So we're going to get closer and closer to 0, but it's positive. So it's from above. Copy the graph of y equals tan theta and add to it the graph of y equals 1 on tan theta. So, we're going to need this big. Let me put this green squiggle back. So as usual, we're looking for when f of x equals 1 or f of x equals minus 1, because we're going to be at the same points. So we're going to go through here, 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 goes through same points. So this is question E, I believe. Yeah. Okay, zeros become asymptotes. So we're going to have asymptotes here, here, and here. Horizontal asymptote. Well, we know 1 over tan theta, so we know 1 over tan theta never equals 0, so we know we've got one there. And min or max, nothing useful here. But what we do know, as tan So as theta equals 90 and theta equals 270, tan theta goes towards infinity and from minus infinity. So 1 on tan theta is going to tend towards 0 at theta equals 90 and theta equals 270. All I'm saying is, when tan theta has these asymptotes, that's when we're going to have zeros. Or at least they're going to look like zeros. Let me just double check something. I think what's going to happen is that we're going to go through here, but we're not going to have the point here. Let me double check that. What question is this? 13. Yes, I was right. So we go through here, and we know that at tan theta's vertical asymptotes, we're going to tend towards 0, but we can never actually be equal to 0. So it's going to look more like a hole at those points. Yeah. Cool. Is that all it wanted? F. What is the range of the reciprocal function? Now, this is interesting. You see how y keeps going up here and down here? The only point y doesn't equal is 0. Because 1 on anything can't be 0. So I wasn't quite right in saying we had a horizontal asymptote. But I did know y doesn't equal 0.